Hi, I'm making a podcast about Rocket Lab taking over this factory.
Rocket Lab taking over, best thing that could happen to us. It's fantastic news.
Is it?
Yeah, it's long-term employment. You've got exciting projects to work on. It's perfect.
Last week, Gary Clark and his workmates were building high-tech boats. This week, they're in the same factory building a rocket.
I've made things from super yachts to warships to hovercraft to sonar domes and now rockets, so it's all good.
I'm Sharon Brett Kelly, and today on The Detail, I'm in a shed, inside a shed, in Warkworth's industrial estate north of Auckland, where a bunch of workers in white overalls are building Neutron, the first large launch rocket made from carbon composite.
This is the next level, this is the next step. No one can deny that the scale of the vehicle, the scale of what we're trying to achieve here is pretty up there with, I guess, anything that's been done in the industry in New Zealand.
It's all come about after Sir Russell Coutts sold his SailGP manufacturing complex to Rocket Lab. And with it comes all the high-tech composite machinery and more than 50 workers, roughly 90% of the workforce, with their specialised skills in building with carbon composites. Today I take a tour of the factory as it transitions from boat building to rocket building. And later in the podcast, I'm inside Rocket Lab's enormous Auckland plant to see how they make and fit tens of thousands of components to a rocket. A lot of the work is top secret. Can I take a photo of that? Or
no,
that? Oh,
not.
Really? But right now, Malcolm Ewing is taking me through the Warkworth plant. He's Rocket Lab's composite manager. Just a few days ago, he was employed here by SailGP. Before that, he worked on Oracle's America's Cup boats in the US.
And then there was about half a dozen of us that set up the shop and turned it from a printing shop into a high-tech boat building shop.
I see you've got the Oracle.
Yeah, a little bit.
I'll go up there.
Old spinnaker to contain the dust in there.
Okay. Quite different to Rocket Lab's Mount Wellington factory,
I think a
isn't
lot
it?
of this stuff.
Bit of a spruce up.
Bit of building you can get away with a little bit messier.
Yeah. Yeah. How does it feel to see that side of the business go?
Yeah, it is a little bit sad. There's some people that are a bit torn because they're quite attached to, I guess, marine and boats and yacht racing. But I mean, it's still better than the alternative, which is having this building not produce anything.
Empty.
So it's cool. It's exciting.
Yeah.
Exciting. But I think this shop will be different because it's not so much production to start with. It's more of a, I guess, R&D or prototyping kind of setup. So
I've been told a lot about the similarities of building a boat to building a rocket because it's the same materials. But what's different?
I think the materials are slightly different and the construction methods, also slightly different. But the idea of using pre-impregnated carbon fibre with epoxy resin in it, high-strength glues and similar sort of bond lines and design ideas around joining components together. Yeah, as far as the super lightweight structures that we've done for the America's Cup or for the F50s, there'll be some differences there for sure.
It's kind of amazing to think that this little town just north of Auckland is part of the space race, really.
Yeah, it would have been really sad for Warkworth to lose this place as an employer because we've had a lot of apprentices through here from Maharangi College and Rodney College.
We're in a shed where a man is sanding down the last keel on the last boat to be built here.
Which is sad, but now we're moving on.
I know. What will you be moving on to, do you think?
Building parts for rocket.
Did you ever think you'd be doing that?
No, but I mean, that's what our job is. I'm a composite technician and that's what we do. That's what they need. So there's only probably 2 or 3 facilities left in the world now that do these boats, which is a bit of a shame, but we're moving on, we're going up.
You're going from the sea to the sky.
Yeah, when we're going across the water, now we're going up.
Yeah. So, what's this? Gosh, this looks...
This is a 52-footer that's off to Australia in about 3 or 4 weeks' time. Nearing completion, but they're quite tricky boats to build, so full race boat.
And so the guys who are working on that will just be able to transfer their skills to
definitely.
making rockets, making Neutron.
Yeah. And the size of some of the parts won't be too dissimilar to building a hull and deck for a boat like that, really.
This site in particular is going to help Rocket Lab advance quicker to our goal, to our end goal. So that was kind of the acquisition of the facility, and obviously being able to retain all of these incredible staff. It's helped us, but we've also, obviously hopefully it's helped the community a lot as well.
Ben Malcolm is in charge of building Neutron, and he also comes from the high-pressure world of America's Cup.
There's a lot to be said about keeping a little bit of the Kiwi boatyard.
Is there?
Yeah, absolutely. To be honest, it's at the heart of the composite structures at Rocket Lab. The same industry has fed our team, so we've supported, and we've also been supported by the Auckland but also New Zealand and composites industry, and a lot of that is founded in the marine industry. So the skill sets of people like Malcolm and the team here that have founded in the America's Cup, they know how to build. They can take a plan and they can execute. So much like the foundation of Rocket Lab down in Auckland, that's what this is. This is bread and butter for them. So you need to have that initially to then build the production afterwards.
Does it mean, though, that if you're not making these boats here, is someone in New Zealand making these boats?
It definitely leaves a little bit of a hole for boats like this. Yeah, I don't think anyone could take it on quite as easily as a place like this, and it is definitely high-tech boat building. It's high-end materials.
And so no one else in New Zealand is doing that kind of high-tech boat building?
Team New Zealand and Albany are doing similar kind of boat building, but
that's it?
Yeah, Southern Ocean. Yeah, there are still places doing it. It's just not quite super high-end.
There's a couple of leading hands here and the supervisor. They're looking at a new Rocket Lab tool. So they're laying up dry fibre and they're going to infuse it. So it's a different method of tool making or boat building as well. Infusion over the last couple of years has become like a staple for the marine industry.
Can I ask you guys how you feel about, going from being part of the boat making business to making spaceships?
Oh, it's not too bad. It's something different.
Not too bad.
Yeah, it's something different. It'll be a good experience. It keeps your job,
Yeah.
Which is a good thing.
A new challenge?
Yeah, very much a new challenge. Yeah, and the facility way the work is totally different. It comes from old school boat building. It's dusty. It's crap. This is nice and clean.
This is clean,
Yeah.
Did you ever imagine that you'd be helping to build a rocket in Warkworth?
Not in Warkworth, no.
So this particular site that we're standing in at the moment, we're going to set up for some more R&D builds for the stage 2. Put in a few more doors, clean a few things up, and then really kick off that, kick into even more, high-speed development of that. So.
Was it kind of not a difficult decision to make for Rocket Lab to take this over? Did it just seem like the obvious solution in a way?
We feel like we've maxed out our catchment of staff that we can get down in Auckland, like as far as the composites industry. So a lot of people like it up here because of the lifestyle. It is obviously very beautiful. As you're driving in, you can see the rolling hills and you're close to the beaches, and people that are used to the industry like us, we all like the outdoors, we like the surf, we like sailing, and it's a mecca up here as well.
And so is there room for growth up here?
Oh, absolutely. It's going to be a different style of building as well that we're doing here with this R&D phase versus the production. So it's appealing to a lot of people that come from the race industry, and not so different. Yeah, we are going to make a lot of those changes that we talked about, but we're also going to, at the heart of it, keep it developing.
Well, considering I'm a mum, so I can only work school hours and stuff like that, Rocket Lab have managed to be adaptable for me and given me what I can do. And I think working on rockets is going to be absolutely amazing. So,
what's your position here?
I'm just a junior composite technician.
What about you? What's your job?
I'm an apprentice, so my job is to learn from these experienced people I started my boat building apprenticeship. I've changed to just a composite technician apprenticeship, and from what I've been hearing through Rocket Lab, it's a great place to upskill, and it's such an interesting area of expertise to learn as well. So I'm really excited, actually.
What do your friends say when you tell them that you help build rockets?
Well, my friends are here, so they're like, yeah, I know.
It's kind of funny that we're standing in this pretty modest, basic shed in Warkworth, looking at the dome of a rocket that's, in a few years' time is going to go up into space. So these two basic sheds hold crucial parts of the Neutron, the rocket that Ben Malcolm is in charge of. They're not your usual sheds. They're rigged for extreme temperatures, depending where the rocket-making process is at. Here's Ben again, and we'll also hear from Rocket Lab's communications manager, Muriel Baker. But this actual thing here is not going to be the final thing that will go up into space.
Oh, one of these will.
Oh,
yeah.
Really?
Mm-hmm.
Okay, because we're talking about years, are we?
Talking about a year.
1 year before it's all ready to go.
Mm-hmm.
Oh my goodness, pressure's on, Ben.
Yeah, pressure's on, Malcolm.
Yeah, pressure's on, Malcolm.
No, one thing that we do love is pressure, that's for sure. Yeah.
But who's actually set that deadline for you?
There are a lot of competing factors for bringing a big rocket online quickly. One of them being the war in Russia. So when Russia went to war with the Ukraine, that took a functioning rocket off the market for astronauts. So now the only company that can fly American astronauts to space is SpaceX. So the pressure for that timeline is to have other rockets so that there's more availability. Otherwise, you're relying on one monopoly for space travel for the foreseeable decade and beyond. So bringing this up in the next year or two is going to be key to having all of that availability for the satellites that need to go up, the astronauts that eventually want to go up as well, and big missions that go beyond Earth's orbit.
Who's your client, who's your customer for this one?
For Neutron?
Yeah.
We don't have customers signed on contracts for Neutron this early in. When we start launching, then that's when people will be coming to us.
I see.
We're working with some organisations for how we develop it, so they are putting money towards the project for better insight. But otherwise, once this rocket is ready and launching, we've got no doubt people will be coming to us.
How much is it going to cost?
We haven't put a figure on it yet. But we're aiming to be competitive with SpaceX's Falcon 9, which is currently flying for 60 to 65 million US per launch.
I'm with Muriel and Ben at Rocket Lab back in Auckland in the darkened control room where they watch the rocket launches. There are billboards mapping the history of this company that was started by Kiwi space entrepreneur Peter Beck in 2006. Now listed on the NASDAQ stock exchange in the US, with 1,700 workers here and stateside, and launching missions every month.
So one thing you'll notice is the security here. So this can be interesting walking through with the microphone that's joined.
Oh.
So we have to tag into every room that we go into. Cool. So on the left-hand side there, when we are launching, customers can come and view it if they're not down in Mahia.
Yeah.
So they've got a little room there, because it is quite an emotional time for some of them. I
For the customers.
Yeah, exactly. I think we've had up to 15, or some of them working up to 15 years on something that takes a few minutes to get to space. But it could be
a failure.
Well, we like to pride ourselves on the opposite, obviously.
I know, but you have. Quite recently in Mahia, you had a launch that didn't go, that failed.
Yeah, and it's a part of the industry, and I think it's more about how you bounce back from that.
Oh, how did you bounce back from that?
Well, we're straight into it and making sure that we're ready as soon as all of the investigation is completed, but it's very thorough. It's safe to say that half the company stops and works on that while the production continues.
Is that hard on your reputation? Or is it accepted in the industry that you kind of have to have these issues to learn from them?
Nothing is really accepted. That's not accepted from our point of view. It's a part of it, but it's not something that we really ever want to experience. No launch company wants to, especially with a record like ours. Yeah.
Okay, so now we're going into FOD controlled area. What does FOD stand for?
Foreign objects.
Oh.
Yeah, so...
Okay. So no food or drink in here?
Yeah, exactly, apart from water bottles. This site has been completely transformed. It was basically an empty warehouse when we took it over, and turned it into what it is now. So they're doing mechanical assembly, putting together all of the different components that then get strapped on either the engine or the vehicle itself.
People are everywhere on this factory floor, mostly men, crouched inside big cylinders, cutting or laminating or sanding fiddly little holes in what look like giant jigsaw boards. Is everybody working on the same rocket?
Not necessarily.
Oh.
So everyone here has a different job for a different mission or a different product. When you walk through to the factory floor, you'll see a line of up to 7 or more different vehicles ready to come through. Generally, the one closest to the door is the one next to go out to the launch pad, but we'll have staff working on missions that are 7, 8, 9 plus more ahead of the queue, because we're that backed up with rockets coming through the floor.
Can I ask you who your customers are?
It's a mix of commercial companies that want to put up a satellite for their business, whether it's taking photos of Earth or communicating through radio communication, internet communication from space, through to government agencies doing science and climate change research. So we have a mission coming up next year for NASA that's going to be looking at Arctic ice melt over the poles. And then you've got a mix of defence customers as well. So you've got the US Space Force that we've launched for before, and then other organisations like that as well.
And that's been one of the, sensitive things, isn't it, that people have questioned who some of those defence customers are.
Sure, so we've always been really upfront about who our customers are, and defence is a really important part of the space industry as well. Everyone relies on it. If you're using GPS to come here to Rocket Lab, you're using a US military satellite.
Do you ever say no to a potential customer?
Yes, but there are rules for what you can and can't launch from New Zealand especially, so those cover things like no nuclear weapons, nothing that's going to, from space, harm anything else in space or here on Earth, and nothing that contradicts any of New Zealand's national security interests or rules that we have as well. So any satellite that wants to launch with us from New Zealand, they have to put through to the government what's called a payload permit. And all of that information is reviewed by the New Zealand Space Agency, and then at the very top, signed off by a minister that says yes or no, with a big tick whether they can launch. And today, every single one of our missions has passed through that process.
It's one of the things, I suppose, that people worry about is what these rockets are doing to the environment. That not only the fuel that's burnt, the making of them, but also the space junk.
Those are great questions. You asked a question about the propellants that we use in a rocket, and our mix is a mix of liquid oxygen, so the air you breathe, oxygen, but in liquidized form, and then kerosene, which is the same that you'll find in all other mechanical parts that use it too. And when one rocket launches, we've got 10 to 11 tons of that mix of propellant for each launch, which is still less than the amount it takes to fly from Auckland to Sydney in one go. And we don't launch at that same frequency as those flights, right? And then to your question about space junk is an issue. It's a global issue. It's not just our own rockets. It's every rocket that goes up. There is no one organisation that manages that whole entire issue, so it's up to each individual company and country to be a good actor in space. The way we design our rocket and the way it leaves the satellites behind is that very little else is left of the rocket in space, because a lot of space junk is actually old rocket bits. So with our, what we call a stage 3, is a little platform that takes the satellite to space and then with its engine can turn itself around and send it back towards Earth's atmosphere to then burn up on the way back down. And that leaves behind nothing but the satellite.
Next, I meet Dylan Ewing, who runs Composite Productions in Auckland. He's the brother of Malcolm, who I've been talking to in Warkworth. They were also America's Cup rivals when Dylan was working for Team New Zealand and Malcolm was at Oracle in San Francisco. So they were both in boat building and now both are in building rockets. How is this different to, making those high-tech, high-end boats in terms of the pressure and, I guess, the challenge?
Yeah, I think very, very similar challenges where you get given a product that, at an initial concept seems almost impossible. And then you put it in the hands of good quality designers and builders, and away you go. It's very similar to an America's Cup campaign, but it's been going on for 8 years now,
Yeah. It's long and drawn out.
Yeah. So this is probably worth a mention.
Oh,
we
there's
call
a
it
conveyor
Rosie.
belt up there. Rosie.
Yeah, Rosie. It's a large 5-axis CNC with a 6th rotary axis with the chucks that you see at the end. And so we can pick up an entire stage 1 cylinder and basically trim it to length and machine all the through holes and put all the datum lines and details and bits and pieces. So all of this that you see here
with the holes
with the holes and right down to countersinking to the really, really tight tolerances is all done.
Rosie's
on
done
Rosie.
it.
Yeah.
Okay,
yeah.
so you programmed
we used to build
Rosie.
this all by hand.
Wow. Okay.
And then we implemented Rosie and
This is where the full vehicle is. You can actually see it now. So the stage 1, you can see how much larger it is, which does the initial burn. So this is quite exciting. So this is the bottom end of a stage 2.
And then why is there that thing with the
little
shape of the kiwi on it?
Well, proud Kiwis, right? I think
It's going up to space.
exactly. Yeah.
Can I take a photo of that?
No, probably not.
Oh, really? Is this the secret end of things?
Well, this is. I mean, you're seeing nearly everything here.
Oh, okay.
This is going to space. This is. You're seeing an engine. You're seeing the batteries. But any photos that make it out into the internet or anywhere like that just get absolutely scrutinised, reverse engineered, and
Is
then
that
you've got
right?
people that can, effectively,
Amateur and
build it.
professional rocket builders.
Oh, you get a lot of criticism from the amateurs as well as the professionals. A lot of them are misinformed, but you also have some very smart people out there that can reverse engineer this.
That's it for today. The rest is a secret. I'm Sharon Brett Kelly, and the detail is supported by the Public Interest Journalism Fund. Today's episode was engineered by Phil Bench. Our producers are Alexia Russell and Bonnie Harrison. And thanks to everyone at Rocket Lab for showing me around. Ka kite anō.